Hello class, today we're going to be talking about representing addition and subtraction problems. Today's learning objectives, students will be able to represent 1- and 2-step problems involving addition and subtraction of whole numbers to 1000 using pictorial models, number lines, and equations. Our DOL is given 4 problems. Students will be able to represent 1- and 2-step problems involving addition and subtraction of whole numbers to 1000 using pictorial models, number lines, and equations with an accuracy of at least 75% or higher. So let's go ahead and get started. So first, let's go over some keywords. For addition, we have more than, plus, total, in all, combine, all together, and sum. All of these words mean we're going to add. For subtraction, we have less, fewer, minus, difference, how much, how many more. These are keywords that tell us we're going to have to subtract something. So let's see how addition and subtractions look using strip diagrams. For addition, when we're looking at addition, we always know that we're going to add when we're looking for a total. If our total is missing, then that means we are going to add. So here, the total is missing. I have parts that I have to combine to give me a total. Even when I have more than 2 parts, if my total is missing, that means I have to combine all of my parts to find what is a total. So when my total is missing, that means I'm going to add. Let's look at subtraction. Subtraction tells us the opposite. That's the kind of cool thing about addition and subtraction, is that they're opposite of each other. So here I have the total, I have one of my parts, but one part is my missing part. So if I have a part that is missing, that means I'm going to subtract. The same is true if I have 3 parts, but one of those 3 parts is missing, and I'm given the total, that means I'm going to subtract. Let's go on. Let's look at number lines. See how adding and subtracting looks on number lines. So when I'm adding on number lines, the important thing is that I start from the left and move to the right. If my number line is moving forward, that means my number line is showing addition. Okay? The opposite is for subtraction. If I start at the right and I'm moving to the left, or how we talked about in class, going backwards, that means my number line is showing subtraction. So let's see how these look in word problems. So let's look at this one. Charlotte practiced violin for 18 minutes in the morning. She practiced for 16 minutes in the afternoon. How long did she practice in all? So let's go ahead and underline the question. How long did she practice in all? Keyword here, in all. That tells me I'm going to add. So I look for the parts that I'm going to add. I have the part where she practiced 18 minutes in the morning, and I have the other part which is 16 minutes that she practiced in the afternoon. So let's see how we would model this in a bar diagram. So again, since I'm doing addition, my total is missing. How many parts do I have? I have 2 parts. I have the 18 minutes that she practiced in the morning, plus my other part, which was the 16 minutes that she practiced in the afternoon. So here my 2 parts are known, but what is missing is my total. So that tells me that I have to add. When I'm looking at a number line, again, remember, if my number line starts to the left and I move to the right, that means that I'm adding. So I started at 0 and jumped to 18. That was my first number that showed. And then I jumped another 16 to get to my answer. So I see that on this number line, I'm moving forward because, again, I am adding. And finally, my equations would show my plus symbol. So all of these show that I am going to add. So let's do one together. At the beginning of the month, a sports store had 45 soccer balls. At the end of the month, the store had 12 soccer balls left. What models can be used to find how many soccer balls a store sold during the month? So again, let's review. On a bar model or a strip diagram, here 45 is my total. So when I'm starting with my total, I have a total. That should give me an idea or a hint that I might need to subtract. So my total is 45. I know that a part of that is 12 because 12 was what was left over at the end of the month. Again, left here tells us we're going to subtract. So that's two clues that we have. We started with a total, and we have the keyword left that tells us we're going to subtract. So using a strip diagram, I represent that the whole is 45 because that's how much they started with. And here I have two parts. I have the part that is 12, which represents what was left at the end of the month. And then I have the second part here that is my unknown. This is the part that was actually sold. So in order to find that part, I need to subtract the 12 that was left from the 45 that they had at the beginning. Let's see how it looks on a number line. Same thing. I start at 0 and I start at 45 because that's the first number that I have. But since I'm looking to see what was left, I have to move 12 units to the left. So this means, again, that I'm going to subtract. If I'm going to the right, to the left of my number line, that means I'm going to subtract, or if I'm going backwards. And an equation is just simply setting up the equation of what I did. I did 45 minus 12, that would give me my answer. So here are three different ways that I can represent a problem. Let's do one together. So a third grade class has 15 girls and 22 boys. Complete the models to show how to find the total number of students. So again, I want to find the total number of students. So my keyword off the bat is total. That means I'm going to add. So I need to look for my parts. I have a part that is girls and another part that is boys. So here I have two parts. So when I fill in my bar model, I'm going to fill in 15 for the girls, and I'm going to fill in 22 for the boys. Again, I don't have a total because that's what I'm looking for. But I know since I have both of my parts are known and my whole is unknown, I know that this bar graph is showing addition. Now, how would I do it on a number line? Again, I start at 0. I'm going to go from 0 and move to the right 15 because that's my first number. So I'm going to start at 15. Then I have to move a total of 22 units to the right. Now 22 is a big number to jump. So what I can do to make it easier on a number line is to break down 22 into easier numbers to make that jump easier. So I'm going to break down 22 into 2 10s and 2 1s. It still equals 22, but I broke it down so that I can skip on the number line a lot easier. So I'm going to add 10. That gives me 25. I'm going to add another 10. That gives me 35. Plus the remaining 2 gives me 37, which is my total. Now, how do I show it as an equation? I'm just going to write exactly what I did. I started with 15 plus 22, which gave me my total of 37. Let's look at a multi-step problem, a two-step problem. So here, students want to raise $400 for their school. They raised $190 by selling wrapping paper and $120 by washing cars. What models can the students use to find how much more money they must raise to meet their goal? So again, how much more here is a keyword that tells us that we're going to have to subtract. Another clue is that we started with a total. This 400 is their goal. That's how much they want to have at the end. So us starting with a total is another hint that we're going to have to subtract. But we know that they raised 190 and 120 So let's see how that would look like. So in a bar model, again, my whole is 140, but I have a part, which is my 190, which was the wrapping paper that they sold, plus another part, which is 120, which was from the car wash. And then my third part is my unknown, how much they still need to fundraise. So a problem like this, I would have to do two things. I would have to probably add the parts that I have first and then subtract that from my total. Same thing with a number line. Okay, again, I started at 400. That was my goal. I moved 190 units to the left. Again, going that way means to subtract. And then I moved another 120 units to the left. Again, I am going back because I am subtracting. And finally, doing an equation. Again, equations might seem like they're the hardest thing to do, but if you start from the beginning and work your way through the problem step by step, you can set it up perfectly. So I started with the 400 that they fundraised. I subtracted the 190 from the wrapping paper, and then finally I subtracted the 120. Step by step, you're able to set up your equation perfectly. Now let's do one together. A farmer collected 80 potatoes from one field. She collected 90 potatoes from a second field and 60 potatoes from a third field. Complete the models to show how to find the total number of potatoes. So again, we're trying to find a total number of potatoes. So keyword here, total. That means we're going to add. So let's collect our information. We have 80 potatoes, we have 90 potatoes, and we have 60 potatoes. So I have 1, 2, 3 parts. So in my bar, my total is missing because that's what I'm trying to find. But I have 3 parts. I have 80 that she collected the first time, and then she collected 90, then she collected 60. So here in the bar model, I modeled my problem for addition. On the number line, again, I do the same thing. I started from 0 and I'm going to jump to 80 because that's the number that I started with. Then I'm going to count and add 90. Since my number line is going by tens, I'm going to go ahead and count from here and count 10, 20, 30, 40, 50, 60, 70, 80, 90. I'm going to mark it right there and add my jump from 80 to 90 equals 160. After I jumped my 90, I'm going to do ahead another 60. And I'm going to count 10, 20, 30, 40, 50, 60. Mark it right here. Then I'm going to do the final jump of 60. So again, since my number line is moving to the right, I am adding. And finally, all I have to do is write my equation. So I'm going to do 80 plus 90 plus 60. And this shows a multi-step problem because I had to do something, I had to do 2 steps. I had to add 80 and 90 plus a 60. Okay? All right. Practice what you learn. Now go to Google Classroom and click on the student handout named Practice Problem. Once you're done practicing those 4 problems, go ahead and do your student handout for a grade.